online. Welcome to the people here. It's really good to get together and have the opportunity to share some experiences of what's going on in the world of DevSecOps. So I'm going to just do a little bit of an intro as to the group. So we've got it on using our rolling slides that I've had here at the beginning. So first of all, I'm Roy Harrow. So for my sins, I'm the chair of this group. If you'd like to do that instead of me, by the way, I'm not, you know, so do let me know. So we've got a small committee here. If you've got ideas as to what you think the group might do to help you or do interesting things for you, please come and see me or David at the back, and I can't see Moses here, or whatever. Just come and let us know if you've got some suggestions. So this is what we're doing today. The slides are going through properly. Next month we have a talk by Joe Goodings from Greenpeace. So I've got a QR code there. If you wanted to grab that, that's all. It's disappeared. That's already up on Eventbrite. It's been there for a little bit actually, but I've not been trying to avoid confusing people by telling people about that as well as this one. Otherwise, you just people get mixed up. I certainly do. So that's going to be a really interesting event. He's done some really good work. It's all about how automation can help, which, you know, and heard some interesting debates over the history about whether or not automation is a good thing or a bad thing. I think most people I know think automation is a good thing. So let's you can come along and talk about that, or hear about that rather. Okay. So just a little bit about the group. We are really easy to find on the internet. You just have to type in BCS DevSecOps group. You get to this page with a picture of me, which I will move on quickly from, and there's some pages up there about what we do as a strategy. So we're sort of on this intersection point between the application development world, or the engineering world, as we will call it these days, and the security folk. And the audience here is typically very mixed, and that's a great thing, because what we want to do is we want to encourage people to understand about security considerations during development life cycles for engineering projects. It might be doing software development for business applications. It might be doing software development for all sorts of things like infrastructure, IoT or cloud, as we're going to talk about. I was talking to Sam earlier about AI. So all of those are projects that are happening in many organizations these days. And security considerations are things that, sometimes aren't always thought of as much as they should be. So what we're trying to do through this group is to try and help people understand. Let's whiz back a bit. Let's come back to here. From a security point of view, what the engineers' troubles are in the world and what their challenges are, and how things like automation can help them. And from the engineers, the software engineers' point of view, how security fits into their project lifecycle. So I'm going to talk a little bit about that tonight. So the remaining slides there are purely some information about the British Computer Society. So if you don't know about that, we're in the BCS London office today, and you can, using the links I got there, the BCS DevSecOps group, you can then find out more about the BCS. You don't need to be a member of the BCS to come to these meetings, but clearly, at some point, if you feel you want to do that, come and talk to one of us, and we can tell you a bit about some of the benefits of doing that as well in terms of helping you with your career. So if you just bear with me, I need to change slideshows because I'm going to quickly go to the more interesting bit. Presentation. I don't have a glamorous assistant to do this. You'll have to put up with me doing this there. Thank you. Okay, so I'm going to quickly whiz on past this little slide here. Right, so just a tiny bit about me. So I've worked in IT for an awful long while, starting out in applications development. So I know some of the trials and tribulations that people doing software development are challenged with, but that world has changed an awful lot, you know, over the last quite a few years. I've also done an awful lot of work in all sorts of other things in service management, configuration management, and latterly for the last quite a long few years, security. I've spent a number of years with IBM, and now I'm working with Sainsbury's, helping Sainsbury's in a product assurance role, and now more around cloud, which is why I wanted to look at the cloud challenges for this particular talk. Okay, so Sainsbury's, very short advert. So it's Sainsbury's plus Argos plus other brands all in there. So there's a lot going on in the Sainsbury's IT world. And the reason I'm mentioning that, like many large organizations, you've got diverse technologies, developers in this country, developers around the world coming across and helping do things. Lots of talent, really good talent, helping, you know, create applications for our internal users and for our external customers. So these are the sorts of challenges we all need to be thinking about, because when you're working with people, you know, and applications that are being deployed in so many different ways, it can make security and DevSecOps interesting, because it's not the same across all of those different areas. David, is that
little thing at the bottom? Does that mean you're recruiting?
Probably, yeah, we are. We are recruiting. Yes, yes. Sorry.
So anyone out there?
Yeah,
we're recruiting.
Yeah, we are. Yeah. Okay. Thank you. So that's enough of that. So the agenda tonight is. Sorry, I thank you. Is I'm going to do a little bit of an introduction to threat modeling. So if you don't know what that is, great. And by the way, I can send these slides out. I don't mind if you want to take pictures of them. That's not a problem at all. But I can make these available. And we will hopefully make the talk available as a recording as well. That will be on the website. So I'm going to talk a little bit about threat modeling, a little bit then about, well, what's the cloud landscape looking like, and then how does that introduce some differences. Put a few buzzwords in there, including Stride. If you've not come across that, I'm not going to go deep on that, but we will touch on that. Have a look at some freely available threat modeling tools, because sometimes tools can be helpful. That's not the end of the world. And I've made a new buzzword. I invented it yesterday. Maybe it's already out there. So my new buzzword is shifting the left. Okay. Okay. So we'll get to that in a little bit later on. So I don't know. It just came to me last night when I was thinking about what were we going to do today, and you'll see why I'm going to focus on that. And it relates to some of the differences in cloud, and how you can actually do shift left, even more left. Okay, right. Okay, and I've got some resources for you and so forth. So we will start off with what is threat modeling. So if you've not come across this, has anyone not come across the term before? Don't worry, if you're shy, that's okay as well. And by the way, sorry, if you're listening online, if you've got any questions, by all means, put them in the chat, and we will definitely pick those up later on. So I just forgot to say that. So threat modeling is trying to help understand what potential security weaknesses might be in an application before you've even built it, maybe before you've even properly designed it. So the idea is, if you're doing it maybe back at the requirement stage, you're trying to help identify some security requirements that might need to go into the spec alongside the functional requirements and operational requirements and so forth. And as you go through the process, you're trying to help build that up and so forth. So it's really, you're trying to get early notice of bad things that can happen from a security point of view. So it's, and the key thing is you want to get there before somebody else does, before the bad guys. And before you've spent too long building the thing, that's going to be expensive to unpick and change. So the earlier you can find out about things, the better. Okay, so that's the whole concept of what it's all about. So I'm going to move on from that one. So why do you want to do it? I've been talking about it already. So you want to get things out early. So this is the whole shift left model, which is trying to move through, move backwards through the development life cycle and say, right, we need to be doing security things sooner than later. The bottom one I'm really keen on, which is encouraging a security mindset. So if you're going to do threat modeling, you need to go out there and talk to the people who are creating the new thing, the application or whatever it is, and engage with them and help them understand what security issues there might be in creating that asset. That's helping educate them, because even if they don't go and do the threat modeling the next time around themselves, hopefully through osmosis, some of this will drip through, and then they will be thinking about, oh, okay, well, that security folk, security people, they were asking about certain controls. Have we got those? So that all helps. And the main steps are, like everything, context is everything. So the most important thing is understanding the context, and that's the business context and the technical context. So there's no point in looking at the technology if you don't understand what that technology is there for. Because you might have a wonderful server, it might be absolutely bristling with lots of functionality, but if you don't know what business problem it's trying to solve, you can't really think about why people might want to attack it, and why people might be tempted to do that, what the motivation might be. And that will then help you think about potential attack vectors and reasons for people doing that. And that will help you explain to the people who are creating this new thing why it's important to think about those bad things, because you need to be able to justify your rationale for saying, actually, there's a worry bead there. Because if you can't say why that's important, maybe it isn't important, yeah? So first of all, you need to understand the context. The business background, is it a financial system? Is it looking after personal information? Is it retail? So if it's retail, like Sainsbury's systems, Sainsbury's and other retail organisations, they want to have their systems up so that they can sell things to people. Yeah. As we know, there's things in the press at the moment, some of our competitors are really suffering. We don't want the same stuff to happen to us at Sainsbury's. So that's an example of, where bad things can happen in terms of availability. There could be other threats, in terms of intellectual property. So if you're a pharmaceutical company, you don't want to have your drug formulae stolen by your competitors or foreign nation states or whatever, someone who's trying to make that drug for a lot less than you want to sell it. So it's a matter of what the business drivers might be for things going wrong or someone attacking things. And then you need to link into, when you're thinking about those business drivers, think about, well, confidentiality aspects, integrity and availability. And I'll talk about those in a minute. So thinking about what can go wrong, having thought about what can go wrong, then it gets interesting. You can now start to think about, okay, these are the important things that might go wrong. What can we do about some of those things? Having prioritized the bad things, and it might be you need to change the design of the function, or it might be you need to introduce some new security controls or whatever. And that's where it gets interesting for introducing the new. But you still need to prioritize and justify all of that. The bottom piece is then just going back and saying, what can we learn for next time round? So these are the activities that I've talked a bit about already. The key thing here is I like doing pictures. So if you find a picture helpful, then do that. If you don't find pictures helpful, that's absolutely fine. But I'm going to show you a few tonight. A picture is really useful because if you do something like a context diagram and you put the thing, the new asset, the new system in the middle, you say what's coming in, what's going out. That's all you need to know at that point. Then you can start exploding it and saying what's going on in the middle. But if you just look at what's coming in and going out to start with, that's a really, really useful exercise. So OWASP, people, I guess most people here will have heard of OWASP. So OWASP provide an absolutely amazing set of free resources for people trying to improve how they do application security and software security. They've got a threat modeling method which covers these sorts of approaches. So it talks about decomposing the application, looking at the inputs, outputs, looking at trust levels and so on. And it refers to this thing called STRIDE, which I'm going to mention in a minute. But it also, on their resources, they don't just tell you about, well, you need to think about bad things that might happen. They've also then got references to ways that you might mitigate that, how you might defend yourself against some of those threats. So they've got some really good resources there. And I'm whizzing through this deliberately because we don't need to spend too long on this. We want to get to some of the more interesting bits. And when you come to doing diagrams, there are different techniques out there. Data flow diagrams, very simple, keep it simple diagrams. You can even be just doing something using draw.io. It could be really, really simple diagrams, whatever works for you. So long as you're looking at the important things, which is the inputs, the outputs. And then another really important question is there any stored data for the new system? Most applications have some kind of stored data. Some don't, but most will have some kind of stored data. Then you need to understand what is that stored data? Where's it going to be put? How valuable is it? And so forth. And what are you doing to look after that? If you come from a software development background, you might know what a CFOM model is. If you don't, have a look it up. It's really good. This is a really good approach for doing diagrams, architectural diagrams, without going over the top. So that's why I've included that in there. Okay, so some diagrams. So this is an example of a data flow diagram. I'm going to come over here so I can just point at it a little bit. So I find this sort of thing really useful. So we're looking at our web application over here. We've got another process over here. Both of these potentially might be in scope. And we've got a browser up here. Now we've got these little lines that are going round. That's showing what's called a trust boundary. So what you're doing there is you're saying, well, actually, that bit there, that's out of my control. That might be just a public user of my system running his browser. Yes, he might be running some of my JavaScript on his browser, but I can't do anything about his browser. In fact, if he decides to unpick my JavaScript and call my APIs directly, I can't do anything about that. So yes, we can help influence, but there'll be a limit. So that's outside of our scope. Over here, we might have a messaging service that we decided to make out of scope and so on. And the reason you might draw some other trust boundaries here is you might say, well, look, you've got the crown jewels of the data in your database, which is your company's crown jewels. And you actually want to say, well, you know what? Maybe that's even more valuable than the web application that's making the changes to it. So you might want to have enhanced security controls over that bit. So that's an example of the kind of diagram you might draw if you're going to do some threat modeling. But the main point is it just needs to be useful, something that's a useful communications aid. Okay, so I just wanted to go through some of the techniques, and we're going to touch on two really powerful techniques that I find very useful. So one of them, as it mentions here, is you could do a really simple approach to threat modeling and just think about what can go wrong from the point of view of confidentiality, integrity, and availability. We'll touch on that in a second. The other one is you can look at Stride. So, okay, what can go wrong with confidentiality? So have you got any data that you care about other people handling? You might not have. Yeah, it might be that all of the data you've got is publicly available. Most systems, that's not the case. Most systems, you've got some data that you don't want other people getting their hands on. So therefore, what is that data? How much do you care about it? And how are you going to be looking after it? Integrity, are you bothered if that data gets corrupted or changed without authorization? It could be accidental or it could be deliberate. So then you get into thinking about, well, why might anyone want to change that? Could there be a fraud angle? Could there be somebody maybe trying to change the price on the price database so they can buy bananas at Sainsbury's for a lot cheaper than you'd normally do? Who knows? And then availability. Okay, well, how long can the business operate if this system's not there? And what would be anyone's motivation for stopping people getting to that system? Now, that's a tricky one because these days, sometimes people just do it because they can in terms of blocking people having access to things. But there might be interesting motivations. Even if you don't fully understand the motivation, if it's important to you that your system's available to its users, its customers, then that's something you need to think about in terms of have you got enough controls in to help defend against that outcome. So that was CIA. So that I find is a really simple approach if you don't need to do anything more. And I think that can work a lot of the time. But another approach you can take is Stride, and I'm putting this in here because if people do threat modeling, everyone talks about Stride. So it tells you up there what it's all about. So first of all, what it's doing is it's categorizing threats. And the reason it's doing this is if you're having a meeting with some people and you're saying, okay, tell me about your application, what does it do? And then you think, okay, well, what could go wrong? What this is doing is it's helping structure that thought process a little bit. So if you're running a bit dry and you can't think of things that could go wrong, then you can use these as prompts. So you can say, okay, well, is there some kind of vulnerability or threat for this application related to people spoofing identities and pretending they are somebody that they're not? Is there a vulnerability for this application here? Could somebody come in and get to my database and pretend to be an administrator when they're really not? Could people do tampering of the data? Could people get to the back-end database and change something without, being an administrator? Could somebody come and do something on your system and pretend they didn't do it? So which is repudiation. So, and then information disclosure. Is there some way that confidential data could leak or be stolen from your system? So is that a risk? Denial of service, we talked a bit about with the CIA. So availability is saying, okay, have you got availability issues? Then finally, elevation of privilege, the E, is saying, is there some way that you could maybe log on as a, one type of user and then end up being able to do things which you shouldn't because you've now somehow elevated your permission so that you can pretend to be a higher level user. And I'll give you an example of how I've seen that in the past. Really, really simple and really, really stupid is messing with URLs. So applications, they'll have URLs, at the end, and they might say, okay, this URL takes me to that page or this page or whatever. And there might be query string parameters on a URL that maybe takes you to maybe someone's bank account number. So years ago, I had a look at one of the banking applications, but I didn't dare mess with it. But I've seen this done on other applications where if you look at the URL, there might be a function that it wants to do. So I'm going to go take you to the admin page. And you might log on as a very basic user who's not allowed to go there. But if you happen to know that URL, that path is there, and you change your URL to say admin, and you get to the admin page when you shouldn't, clearly that's not right. Another opportunity is just changing maybe a query string parameter to put somebody else's customer ID in and just getting to their record. You might think those are stupid, but I've seen examples of where applications allow those things to happen because nobody thought anyone would do that. Yeah. These days, most people would think about that, but I'm talking a long time ago. But I've actually seen this on real business applications because nobody thought that was likely to happen. So we talked a bit about bad things that can happen. Just to sort of turn the tables a little bit, it's good to think about, okay, well, what can you do about it? So for spoofing, you need to think about, well, controls related to authentication, maybe digital signatures. If you've got secrets, so secrets these days is a big, interesting topic. That might be your password for your database, things like that. Or it could be someone's credentials to log on to a system. Where are you going to store those? I've even seen secrets now not being just found in places like GitHub and so forth. Secrets being found in executables, in Lambda functions, in cloud services, and all sorts of places, which are quite interesting. So secrets have a habit of leaking. So just bear that in mind. Tampering, so you need to make sure you've got proper access controls, maybe role-based security, but also controls to check whether things have been tampered with. So actually, detective controls as opposed to preventative, to look up checksums and so forth if you come across those. Repudiation is about making sure you really do authenticate people properly in the first place, and having audit logs to say, right, that person logged in on that time, and we know that the action was done by him because we had his credentials and so forth, and potentially signing transactions. Information disclosure with backward access controls, but also it touches upon encryption. If somebody's got some kind of access to either a data stream or more likely a data store, and the data's not encrypted in a way that's useful, then potentially they could get to the data when you don't want it to. Quick word on encryption. Most cloud services these days will just do it without falling out of bed. Just think about what you're getting when you get encryption as a default. It's better than nothing, but think about what that's mitigating you against, because if you've got access to the cloud account and you can get in there and you can read that data, it doesn't matter whether it's encrypted or not. What that encryption is really doing, if it's encryption on the hard disk in the cloud server, is mitigating against that cloud service provider taking the hard drive out of the server, selling it on eBay. Now, they're not going to do that. You hope. But that's the kind of thing people used to do years ago, was they would go and buy drives off eBay and then have a look at them and see what information they could find on them. Just encrypting the data on the hard drive doesn't stop another authorized user getting in and looking at it. That's a much harder challenge. Denial of service, so things like throttling or putting quotas. So looking at things like if you've got an API interface, maybe doing some rate limiting to say you can't hit that API too hard, too many transactions too quickly. And again, if you possibly can, only let authenticated and authorized users hit that API. Don't have a public API open to the whole world if it doesn't need to be available to the whole world. An elevation of privilege, again, access controls, and finally, hardened system configuration. So these are general things. None of these are specific to cloud, but there are cloud dimensions to these. Okay, so I'm just putting this up here as a source of reference. So I'm not going to go through these, but if you want more information on where to go for security controls, as opposed to bad things that can happen, OWASP have a really good list here. So OWASP have their top 10, but that's bad things that can happen. These are 10 things that you can do to try and stop the bad things happening. Don't think it's necessarily a one-to-one mapping between these and the OWASP top 10 vulnerabilities. But you can see I've highlighted some things here which I think are really important, especially in the world of cloud. But you can take your pick. So I think that's a great resource to go to. And the reason I've got the little man with the little light bulb here is this gives you ideas. Yeah. So if you're struggling to think of what can I do, I can see these threats. Where do I go now? You've done some threat modeling and you're just running dry. Things like resources like this can be really useful. The other thing OWASP have is really good cheat sheets. So turning into a bit of an OWASP advert, but there's nothing wrong with that because they've got some superb resources. And if you're not sure how to do secrets management or input validation, okay, input validation is one of the most common crimes that you'll see anywhere, because people think they're working with maybe a trusted, it's one application talking to another, or when working with a logged on user, why do I need to validate the inputs?
Right, just to add, they also have some really nice vulnerable by design programs.
Thank you. Yeah. Okay, so if you didn't hear online, somebody was just saying that OWASP has some very good vulnerable by design programs to help people go and do assessments. Thank you. That's very helpful. Okay, so there's some good options there if you want to look at those. Okay, moving on to cloud a little bit. So we're sort of getting closer to cloud now. So cloud isn't just one thing. Cloud is lots of different things continuing to evolve. And I haven't even put AI up here. So AI is arguably a branch of software as a service, depending on how you view it, maybe platform as a service, depending on whether you want to use Lego bricks or whether you want to use a fully built car. So if we start at the bottom, where clouds came in probably 10 years ago was very fundamental computing services. So basically you're renting time on somebody else's computer to basically rent a virtual server. Your virtual server will be in a virtualized network environment. You're renting some data center facilities that you don't even see, you can't get anywhere near. And you're renting things like storage. So typically it's compute, networking and storage are the main things that you're talking about down there. And it's all virtualized. So you don't really know what's underneath it. But that's okay in many cases because most of us don't need to know. So that's the sort of the infrastructure as a service layer. The next layer can get a bit more confusing. So platform as a service is a way of trying to help people build applications quickly. But there might be some middleware for maybe messaging, things like that. There might be some application runtime environments which are pre-configured for you to drop your application into that somebody else is going to support for you. And that's great, because if you don't have to patch that, somebody else is doing that. That might help. That might be really helpful. Java runtime is an example of that, where it might be databases and so forth. And another application runtime that I ought to mention, because everyone is doing it, is container runtime. So that could be Kubernetes, or it could be Docker, or what have you. It doesn't matter, but some kind of container runtime is everywhere these days. So, and the development stack, lots of organizations now have developers all around the world. You might want to provide a virtualized development stack to your developers, so you can give them a pre-configured set of development environments to get them up and running quickly. You get a new member to the team in, and you can give them that virtualized development environment with all of the prereqs they need for a particular project, even not just for a cloud environment. It might be very specific to a project. So you can tailor these. So these are layered. So that's PaaS. And then on the top, SaaS. So this is like everything that we all use in terms of online services. It might be Workday for doing your HR and payroll and things like that. And almost any business process. CRM, ERP, HR, all of those abbreviations that we love to hate. Collaboration tools like messaging. SaaS now includes many IT things which are sort of somewhere between PaaS and SaaS. So things like services that you might want to use to construct your application, such as something like Kafka. Is that SaaS or is that middleware? I don't know, and I don't really care. You can buy that as a SaaS, effectively as a SaaS service. You might want to buy a bit of a database management system. It could be down here. You might call that PaaS. But that database management system is probably going to have some kind of management console. I don't know, is that PaaS or is that SaaS? So you can get in these arguments. It doesn't really matter, but the world of cloud is very mixed and very varied. And the reason I'm stressing that is the threats to each of those layers are different. It's not all the same. It's not one size fits all in terms of if you want to attack these things, very different to attacking those or those.
And the responsibility as well.
Absolutely, yes. So Moses just said the responsibility word. Let's come on to that. So,
Oh, sorry.
no, brilliant. No, thank you. So in the cloud world, one of the biggest, most important things you need to understand, we all need to understand and not forget about, is this concept of a shared responsibility model. So if you've got your own on-premise data center, orange is the bit that you've got to be responsible for and look after. You're responsible for the whole lot. That's your problem. That's your data center, your tin, your servers, and what have you. You might outsource the management of it to somebody, but you're just delegating that responsibility to somebody else. Ultimately, it's still your problem. If you're in the cloud and you're doing infrastructure as a service, well, actually, you're renting somebody that's looking after the servers, providing you with compute to a degree. Okay. But you notice it says operating system on there. Well, does that mean you don't get an operating system? Not really. So I think operating system's a bit of a grey one, because you go to AWS or Azure or GCP, you're going to get almost always, you'll start up a virtual machine in their cloud and you're going to get an operating system on it, almost always. Sometimes you can get an empty box and put your own one in it. Almost always you're going to get one. Do they patch it after day one? Mostly not. So you've got an operating system that was patched at some point in time. Who knows when? Over to you now. So just bear that in mind. Yeah. And you might want to put some middleware on there. You might want to put some database management server on there, or you might want to put a web server on there. None of that's provided. All you've got is some compute resource that you can use in a nice elastic way where you can scale it up, scale it down, you can monitor it, you can link it together with a virtual network. You're still responsible for doing a lot of functions.
Mutability.
Say it again.
Immutability.
Immutable. Well, that's another matter again. Yes, what say. Yeah, I saw. Say, Sam.
So one of the things that always makes us quite nervous as some subject to the TSA is, of course, if we buy a SaaS or PaaS, we need confidence that that's being done for us. We need to know, and that's quite. We often don't get that.
Okay.
The service model.
So I cover that on the SaaS bit, but thank you very much for raising that. So how do you even know SaaS is any good? How can you trust it? Right. So we thank you. That's a really important point. So PaaS, you might be providing your data, you might be putting your business applications on top of a runtime stack, on top of maybe a database management service, a middleware. It might be a Kubernetes environment that Amazon or Microsoft are running for you to a degree or quite a lot, depending on what it is. They might look after the master nodes on a Kubernetes environment. They might not patch for worker nodes. That might be down to you. So you need to look at the fine grain in the shared responsibility model for every particular object in there. And if it's down to you to patch those worker nodes, bear that in mind, because that's not a simple thing. And then we get into SaaS. Well, on the face of it, this diagram suggests everything's being done for you. Okay. I don't think this picture's correct from that point of view. So I didn't have time to adjust it because it was too complicated. I still think you're responsible for your data in SaaS. Probably not the application, because that's the bit you're probably renting from them. But the bit you are responsible for with respect to your data is defining things like access controls. Who can get to the data? Who the users are? What the different user groups might be? Things like that. Okay. And then Sam was talking a bit about, well, how can you even trust that SaaS? What can you do? So what you can look for is independent verification. Easier said than done, but the sort of the typical things you might go for. You might say, have they got any? Do they comply with any cloud security standards? So there are things out there. So they might be Cloud Security Alliance have a STAR program, which applies with various sort of different cloud service providers, and some SaaS vendors might align with that. You could ask them, do they comply with any security standards? Things like ISO 27001. Have they been certified independently against that? Do they have independent pen testing against their application? I would also ask them, are they being certified by auditors against something like SOC 2? If it was a big enough, important enough application that I really cared about. So what SOC 2 does is, rather than the SaaS service provider allowing every one of their customers to come and poke about in what they do, they will pay for a firm of auditors to come along and do that auditing and verify that their controls are as they say they are. And if you ask them nicely, they will allow you to see the output of that report, quite commonly under a confidential arrangement. Sometimes it's public, but more commonly it's a confidence. And then you can see, warts and all, what the auditors have said, and maybe a summary of their pen test results. So that will give you confidence. It's not the whole story, but it's very hard when you're buying SaaS applications to have full confidence.
Can I suggest an edit to the diagram? You switch the data and the application rows.
Yeah, then that's a really good suggestion, because then we can have the coloration on the data. Yeah. I still think aspects of the data are being looked after in SaaS.
They're gonna do the backups, aren't they?
Well, they're storing it. Yeah, but what they're not doing is they're not doing the access controls in a way that's meaningful to the customer. They are doing the access controls from the point of view of the SaaS platform, to make sure that no other customer can get to your data, and you hope that's what they're doing.
Maybe there's a user layer missing.
Yeah, so we need to work out what that layer is that goes at the top. David?
Isn't the frightening bit of that, you're almost preparing us for the AI you've excluded?
So AI at the moment is mainly just a SaaS, but a very difficult SaaS to understand. If you disagree, please throw rocks or whatever. Yeah.
Another way to talk about SaaS is using RACI.
Yes.
As a application owner, I am accountable, but it is the SaaS provider who is responsible. So they're doing all the work to maintain.
Yeah. So Armand's making a very good point. Even if the SaaS service provider is responsible for providing that service. As Sam was saying, it's your responsibility to choose that SaaS service wisely, because ultimately it's your company's data, possibly your customers' personal information, possibly their credit card data. It's your responsibility to make sure that data is being looked after properly. If you now choose to delegate that to a SaaS service provider, it's your job to make sure that that service provider is good enough. That's not easy. So AWS produced their own shared responsibility model. Microsoft, Google, and lots of other people do very similar ones. So the bottom bit here is saying they do, their mantra is they do security of the cloud, in other words, of the cloud services, and the customer is responsible for the security in the cloud. So in other words, your usage of those services. So even infrastructure, infrastructure as a service, you leave the keys to the kingdom. You know, if you leave all the doors open and let anyone get to your compute, you can't blame the service provider.
I think that's why Google tends to talk about it being shared fate.
Yeah,
because your failure still looks bad on them.
That's a good point actually, because they don't, no cloud service provider want their customers to be upset because bad things have happened. No, it's not good for them. It damages their reputation. So if you're looking for, going back to the threat modeling world, some inspiration around, well, what can go wrong in the cloud world? OWASP have their standard list, their generic list of things that can go wrong. The Cloud Security Alliance have a nice list called the top threats to cloud computing, which I'll cover in a second. So that's a really good resource. And it's got like a prioritized list of bad things that can happen in the cloud. There's also the cloud native security that OWASP produce. And there's a couple of sort of lists of cloud misconfiguration, some mistakes that people commonly make. So you can go and all of it. I'll share the slides, and all of these links are there. And we're going to have a quick look at some of these other ones. So these are useful if you need inspiration, and if you're looking at if you're doing an assessment of a cloud service and you want to think of, okay, have I thought of all the things that I need to? Okay, so the CSA, these are the top four, pretty much, I think, in order of priority. So the big one there is assuming that your cloud service provider is doing something that they're not, in terms of securing things in a way that you think they are, because you've mistakenly thought they're doing everything for you. Okay, and therefore not locking down your use of the cloud as much as you should. That's the absolute number one big mistake that many organizations make, and many of us, so therefore tools such as cloud security posture management, horrible bit of buzzword, but cloud security posture management came out a good few years ago now as a thing. Tools like that can go and look at, you can point tools like that at your cloud estate, and it can tell you, you've got these S3 buckets here that are open to the whole world. Do you really want that? So, and many other findings. Identity and access management, number 2, in cloud. This is, you don't see anything up there about networking. Okay. Cloud networking is really IAM. So, and that sounds a bit of a misnomer, because that's how you get to stuff in the cloud. And
sorry, I don't know if you can hear me or not. I totally disagree with that.
Oh, right, that's fine. No, let's have some arguments. No. Yeah.
So networking is totally different. Yes, it's an open public network, but IAM is a key point to this. But networking is different because in essence, you have a service layer there or shared model for how you're getting in and out, which includes firewalls.
Okay, I'll take it back. So thank you for the correction. Okay. I do stand by IAM being really super important, but I stand corrected. So thank you for.
No, it is important, but say
but you're absolutely right. Networking as a concept still does exist in cloud. Absolutely. Thank you.
And you could do it wrong.
Yeah, and you could still do the networking bit in cloud wrong as you could.
Very wrong.
Yeah.
Very.
Yeah. So thank you for that. That was very helpful.
Just in your support, AS numbers are deprecated from July, so networks are really the keys that the cloud providers provide now.
Yeah, that's another matter. Yeah. Okay, I need to move on because there's a lot to cover. So identity access management, the main sort of two crimes there that you'll see people making are accidentally making things available by not having access controls on them appropriately, or security roles having too many permissions. And that's a really hard one, because if you want to then refine those permissions without breaking applications, it can be challenging. Some CSPM tools can help you do that, but you still have to have the confidence that you're doing things right. So some of those, for example, we're going to look and see where permissions have been used over the last month, 6 months or year. But you then need to be super confident that that time period is representative of all of the behaviours that that application needs to exhibit. Insecure interfaces and inadequate selection and implementation of cloud security strategy is basically not really understanding what you're buying. You're buying the wrong thing and not therefore securing it properly. So I'm going to move on quite quickly. I'm not going to go through these ones at all, but you can see here, this is the final 7 out of a list of 11. For some reason, the CSA decided to go for 11. Okay, so you can see that list there of the final 7, and I put examples underneath each of those. And this document is really useful if you're looking for inspiration as to bad things that can happen in a cloud environment. So this page and the next one are just a couple of sort of resources that I found to say these are like lists of common mistakes that people made. And you can see there's a massive overlap between here and what the CSA said. If we look at the next one, this is a slightly different take on it. But again, things like this can be really useful resources to go and look at. Right, okay. So in case you didn't think that everything was rosy, in case you thought everything was rosy in the cloud world, this page here is talking a little bit about some occasions where there have been exposures because of things like poor configurations on cloud. So there was the Darkbeam one where 3.8 billion records, so quite a few were exposed a couple of years ago, and then a few more years before that, Toyota had a problem. And last year, I don't know if people are aware, there was a Snowflake thing. So Snowflake is a big data warehouse system. There's a whole query as to quite what it was that went wrong there, and it didn't affect all of their customers, but it affected a fair number. And their service is hosted in Azure, it's hosted in AWS, so it's a cloud-hosted service that Snowflake as a SaaS service provider really hadn't quite set up properly somehow. Right, so what I'm going to look at then is an example of a typical web application that you might host, and then we can then have a look at some of where things might go wrong, and then how you might implement this in the cloud. So this is you might draw a picture like this if you're doing some threat modeling in the cloud. You might say, okay, well, what have we got there? So that's a very generic picture. And you could then come along and actually have a look and say, okay, well, what's behind that? You've got the browser user interface with its JavaScript and the back end and microservices and so forth. And you can say you might even have some SaaS at the bottom. So that's a very common model. So that's what this is describing. So that's there. You might draw it using fancy icons and diagrams and so forth, which represent what's the cloud service providers services, from Azure or from AWS. But it's pretty much the same thing. But what's happened is, just a second, somebody wants to come in. What's happened is I've added some bits on here. So on the picture before, it was really crude. So this might have been release 1 in terms of the design, where you said, okay, well, we've got the browser talking to some kind of internet-facing web server. So as a security person or the team who are doing the security review, they might have said, well, maybe some things could go wrong here in terms of denial of service and various attacks. You go through to here. We've got some cloud security controls, which you can rent from the likes of AWS to Amazon CloudFront can help you with performance because that's a content distribution network, so that can make sure you've got presence all around the world. AWS Shield is sort of denial of service protection. AWS WAF is a web application firewall. So if you glue those things together, you've now got some extra protections on the outside. We didn't have one of these before, so this is now a load balance broker. I mean, anyone that's doing an AWS application would always have one of those in, I'm sure. But that gives you some resilience because you can now have lots of these things here. So if one of those fails, it'll go to the next virtual machine that's still there. So that helps with your resilience. And, you know, we can put fancy symbols on there if we want to do Kubernetes. And we have some kind of state management. So you might decide to do that using an in-memory database like Redis. And you separate the things. And over here, you might have some static content which is being displayed for your images and so forth, you know, your GIFs and all of that on your web pages. This raises a really interesting potential vulnerability. That is still a potential route for data exfiltration. So if somebody got into your cloud account, and this is legitimately public because it's absolutely public by design, and they start to go and dig around and get some sensitive information, and they see, oh, you've got an S3 bucket here, which is being used for the static web content, and their role, that they've managed to assume in your cloud account, allows them to write to that, then they can send stuff out to wherever they like. So the way to control that is you need to limit who can write to that. And that's not easy. Well, someone's got to write to that because they've got to put the data in it in the first place. Okay.
Sorry, right, by default, S3 buckets aren't public. So AWS have changed the rules now, and they're by default, they're private. You've got to make them public. And generally, when you do that, there's generally rules in place to ensure that you know it's happening. I work in cloud security quite a lot, and we generally put rules in place that users cannot put buckets public unless there's a legitimate reason to do that. So by default, we're defaulting secure and keeping that bucket private unless we really need to, and that's a very fringe edge use case, and that wouldn't generally go through the AWS Shield, WAF, and via the AWS Cloud Front distribution as well.
Yeah. So absolutely. I mean, the network routing to that isn't right. Apologies. The point I was making was you might consciously decide to use an S3 bucket for some static web content, which, you know, is arguably a perfectly legitimate design decision. And as the person has just said on the call here, you've got to consciously do that these days because AWS and the other service providers are making it hard for us to make mistakes now. They are helping, but having consciously decided to make that public for what you want to go in there, how do you stop other things going in there? So let's move on. We're going to go down a rabbit hole because that's probably not the most important thing. But thank you for the input. That was very helpful. Okay, right. So you might decide to use a fancy threat modeling tool. So I had a go at taking this diagram here, which I did using, I don't know, Draw.io and some other things, and it's not a proper architecture, but none of these are. And then I went into one of the threat modeling tools. So this happens to be Erius Risk, the Community Edition. I'll talk a bit about some of those tools in a minute, and translated that diagram into here. So this is an example, as if you have access to one of the tools out there, or to be honest, Draw.io, because Erius Risk is sitting on top of Draw.io for its graphics, which is absolutely great. You can end up with a picture like this using the proper symbols. The point is, if you then carry on with this in the tool like that, the tool can then help you identify some of the threats, and I'll talk about that a little bit more. But that's just to show you how you then maybe go to the next step. Okay, so we've talked a lot about the different layers. I'm going to whiz through these because we could get stuck down these quite for a long time. But in the infrastructure's service layer, you can then look at what some of the common threats might be. We've talked a bit about some of those as we've been going on. And I've listed some of the things you might then consider in terms of mitigations, but these are really more runtime or build time things. They're not things to do with the design. So my view on threat modeling is it's trying to help people at the requirements and the design stage, but you still might want to do these things later on in the world. The PaaS layer, similar kind of failures that people might have in terms of allowing people to access things when they shouldn't. And again, there are tools out there that could help you during the runtime assessment. Actually, let me just go back and take that back a bit. So the trivia one you can do before you get to runtime. So if you're creating things as using infrastructure as code, you can actually do that. And I'm going to talk about that a little bit later. And then if you get into the application layer, you might have front ends. Lots of threats to front ends. Front ends are really hard to deal with. I talked a bit about validation before. Any validation you do in the browser is completely worthless because people can completely bypass that. So don't trust that. And then you can do things using headers and so forth. They are useful, but they're not the whole story. And then you get into, so if you've got an architecture where you've got maybe like a server-side backend, there'll be all sorts of threats that could potentially happen against that thing there. So these are examples of things you might look at if you're looking at that part of the architecture. So the point I'm trying to make here is when you're doing the threat modeling, the considerations that you're looking at are very different depending on where you are in that diagram, in the architecture diagram. Okay, I really want to whiz through as quickly as I can. And then you might get into microservices where you've got similarly different types of threats and mitigations. And now I want to talk about the traditional shift-left model. So traditionally, people come up with pictures like this. So I made this up by making up numbers. This is not based on any academic research, okay? Just to make the shape of that graph look nice. Okay? But this is meant to be representing the relative cost of fixing a problem at a particular time in a project life cycle. Academics and all sorts of people have done proper research on this and can maybe give you a number that's more believable than the one I've completely manufactured. But it doesn't take a lot to work out that the later you leave it to fix something, the more it's going to cost. And that's what we're trying to do with threat modeling. We're trying to fix something around here during a requirements design stage, ideally before we even get to build it. And the reason you want to do it before you get to build it and before you get even to the low-level design is because if you're doing a threat modeling properly, you might identify things that need to be incorporated into the design that you hadn't even thought of. So therefore, how can you complete the design until you've really done the threat modeling properly, let alone the build and let alone the rest of the deploy? And the really interesting up here is, in the bad old days, that might have been your only security control. Before we go live, we're going to do some pen testing. And that's really bad when you are in that position because the project's probably already going late. We probably never had any time in a project plan to fix anything anyway. So if you find anything, the chances of it being fixed before it goes live are probably minimal. So it's doom and gloom all round.
And you won't look again for another year.
Well, it depends on. I'm assuming you're doing a pen test because you're actually being proactive and you're doing it related to a new application or a change. Yeah.
And, the graph is very based on the data. Quite correct. It's around like 3.5 to 5 times.
Some people say this is exponential. I just did a shape that I like the look of. Yeah. So now sorry, you got. Sorry, go back.
If we could go back to the graph, because what we've done is we do, as soon as we've got the initial requirements, we do threat modeling. We then go back and we feed in our new requirements with the threat modeling.
Yeah,
and then check that.
You have a double.
So we have a
spin.
double cycle, and that seems to work really well.
Yeah. So that's wonderful. If you've got an environment and an organisation that has the appetite to do that, that's really good because then you're double checking. That's really, really good. Okay, so in cloud, but not just cloud, but particularly in cloud, you'll find that a lot of people use this thing called infrastructure as code, which is where definitions of the runtime environment, typically virtual servers, virtual networks, and storage, and what have you, will be written down as in a language and then saved in a source code management system like GitHub. So you've got source code, which is defining what the runtime environment looks like, called IAC. So at various points, you've got the opportunity to think about that, okay? So during the project requirements, during the high level design and all of those things, you need to think about, well, where's that infrastructure as code gonna come in? Now, during the project requirements phase, it's too early. Typically, the infrastructure as code doesn't come in until you actually start defining the cloud requirements. So you've gone down a little bit from the way. Okay. There's nothing wrong in that, but wouldn't it be nice if we could help get the infrastructure as code right earlier? So if you're looking at that sort of typical threat modeling life cycle, if you could come and have a look up here where we do maybe the high level design and say, okay, well, what can we do to make the infrastructure as code better? We stand a chance to actually do something about it before. So this is actually suggesting there might be you might actually look at some of the potential threats of your application to say, have we got, have we actually hardened the target environment before we built it? Have we actually included a design to put something like AWS WAF in there, or the denial of service shield service? So those things were missing in my original design. So you could look at the high level design that didn't have those things in. We could say, right, you've got some missing components, put those on the spec. We haven't even built anything yet, but just make sure they're included in the definition of the thing you're going to deploy. So you can still do things even before you've built that. So that's very much something that you can do very usefully. So I put an example there about S3 buckets. Yeah.
Some of those components come with price tags as well. The sooner you get those into the spec, the sooner you're having that fight. You want that fight before you build something.
Yeah, you don't want to be changing. That's a very good point. Yeah. So almost all of these components have a price, I would say. Yeah. Some are quite expensive.
Yeah, they are.
There's a different approach to this now, though, because most stuff is now building landing zones. So in essence, when you look at most organizations, they have the cloud center of excellence, which deals with the cloud, and then they build out landing zones. Yeah. So a lot of this stuff is rolled into policy as code. Yeah. So therefore, they build a standard approach and pattern for how they will build a landing zone, and then the development teams get dropped into a landing zone for a standard set of user requirements. So a lot of the stuff is wrapped up to that and fits into the infrastructure as code tooling that they then use, such as Terraform, but then that passes through, as you were stating earlier, such as Trivy or TFSec, which then enforces the policies when they build it out. So that's when this enforcement piece of work is done. But the threat modeling would have been done initially when the platform was first initially stood up.
Yeah, no, completely agree. I'm going to touch on something a bit like that, but I haven't called it landing zones. But thank you so much for that, because that is a bit of jargon that I haven't introduced. So if you haven't come across the landing zone model, it is a really useful concept, and very powerful. So so this is my touch, my sort of slightly joking idea of sort of shifting the left. Okay, so as well as the landing zone concept, which is sort of designing like a whole world. One of the things that many organizations would do is have reusable components within their infrastructure as code. So you might say, okay, this is a definition of a virtual firewall or something like that, or some other security, or whatever it is. And if you're doing the design for that reusable component, you can actually do some threat modeling at that point and make sure that you thought about the different security characteristics for that. So before you've even created the application, before you've even decided to do that, obviously make sure you design that, so those reusable templates of the modules early. So then you can actually take those reusable modules, you can use parameters to parameterize them and then deploy them multiple times. Then you can deploy them as cloud resources. And then down here, this isn't using the landing zone wording that was said on the call just a second ago, but I think I'm going to suggest this is similar, but it's not exactly the same. Many organizations will have a process for creating and vending new accounts. For that, you'll have some security policies which will feed into that. You need to do threat modeling around the implementation of those security policies, which are then potentially going to implement some guardrails as part of the deployment and as part of the runtime. So I don't know whether that covers everything that you were suggesting on the call, but that was my sort of simplistic take on it. And that's what I'm saying, you know, in terms of you can go back even further than the beginning of the application, because what we're talking about here is getting the template for the world that you're going to build right and get those reusable factors in. And therefore you're starting really, really early in the whiz through. So I'm going to talk a little bit about security tools. So there's all sorts of features that you might look for. I'm going to whiz past that. There's a whole load of security tools out there that you can use for threat modeling. There are some out there that are completely free, some that are free to try, and various things in between. The ones that I found most useful are for different reasons are the Microsoft Threat Modeling tool can be useful, depends on what you want to do. OWASP Threat Dragon is great if you want to draw some pictures and it helps you structure your thought processes. Irius Risk is very much a commercial tool, but there is a free tier. You can do some very useful work as a learning exercise. I think if you get beyond learning, you're gonna need to get to a point where you're gonna have to buy it, I'm sure. But you know, if you're just trying to learn about this topic, it's very, very powerful. And then there's a whole load of other ones down there, including Threat Modeler and Threat Canvas. But one that I'll call out as another one that people might not have come across is AWS have got this thing called Threat Composer. That is really interesting. What I'm going to do, I've got some. I don't think there's really time to demonstrate the tools. If you want to do that, I've got one of these started up on my machine. We can look at that later. I've got a couple of screenshots of some of these tools. So for example, the OWASP Threat Dragon tool, this one here. You can actually follow that link and you can actually get to like an online version of it. So you don't even need to install it. You can install it as a Windows executable or as a container. And what it lets you do is it lets you draw pictures. Okay, so a bit like the picture that I had earlier. And what it then lets you do is each of those objects on that picture, it prompts you to think about the threats and the mitigations. I've not found it help you particularly to think about what the things are that could go wrong, but it might be I'm not using it properly. So I'm very, very happy to be corrected on that. And then as you see at the bottom, it might list these threats. And then you can this is an open template. This is for you to fill in. It's not generating this. So this is for you to come along and say, okay, this is a threat. It gives you some sources of potential wording that you might want to go and look at, but it's for you to decide what you want to put in. And then again on a mitigation side. So you can go and do that. So you can see you've got a couple of threats there, and then you can generate a nice report at the end that shows you, these are all the things in my application with the various threats and mitigations. So you could use that to review what you've got. So that's all available. OWASP make that available for free. And I think it's not bad. So a little bit of a look at the Irius Risk one, if you've not ever seen that one. I think this is a really, really good tool. I don't know anything about the commercials, but as I say, I'm sure to use it, you'd need to pay some real money. You can do some really good things with it for free for learning, as I said earlier. So you could come along and you could draw a diagram of the world here. You could put some AWS assets in there. Whether you think that's a good design or not is another matter. Yeah, this is purely just to generate something. And then having done that, you then go in and you say, now generate me some potential threats against that and potential countermeasures. And then it's got like a Q&A model where it can actually ask you questions and say, have you got this? Have you thought about that? And then if you do some of those things, it will then quiesce it'll suppress some of the findings. So that's the sort of thing you can do there. It might come up and say, okay, like I found these threats. And then mitigations. It's not religious to sticking to the Stride thing. It will link things to Stride if that's helpful. And then it gives you like here, so you can say, give me the top 10 high impact issues and countermeasures and so on. So I'm going to whiz through that. So you can see what it generates is pretty good. What it knows about is it understands the objects that you're putting onto the diagram. And it understands the type of threat that they have, which is very similar to what the Microsoft Threat Modeling tool does. The difference is the Microsoft one out of the box pretty much only understands Microsoft things, whereas this understands a much greater range of things. But there's a big difference in price because the one is completely free. So Threat Composer, you can go and do this online. There is a way of downloading it if you want to run your own version. They actually say that if you run it online, they promise that no data that you're putting in is going anywhere. If you're worried about your dirty washing going somewhere, they claim that's all safe. What you can do, they've got a structure for defining threats, which is very much like the wording that you might be used to if you were defining risks. So you could say, you know, something can happen in such and such. So it gives you a really good structure for doing that. It's got some, you know, some reports and so forth. I'm just gonna, what's going wrong? Here we are. So you can go in and you can describe what the application might be doing. It doesn't have a diagramming tool. You can put a diagram in if you've done one, but it doesn't do any diagramming. It's not generating anything from the diagramming. It helps you, prompts you for coming up with risks and things like that. And it's got a structured way of helping you think about the language, but it's very much up to you to do that. I'm just trying to see here, look at the structure. Okay, so if you look at that first threat there, so it's saying a threat actor, so that somebody can do something. Then it's talking about what they can do, and then it says which leads to, so they're then looking at the consequence. So you're trying to get people to think about the consequence of the attack, and then it says resulting in, and so on. And then, so I think it's a good structure, and they actually have prompted to help you think about structuring the threats. So it's a different way of doing it. It's not doing it all for you, but it's helping you think through the process. So you see, then it can generate these mitigations and so forth, and some nice reports at the back. And you can even document assumptions if you wanted to. It doesn't do anything magical with those apart from include them in there, and you can link the assumptions to the mitigations or to the threats and so forth. So it's providing you with a degree of management of the information, which I think is very powerful. So I appreciate we've gone on for a fair while now. I'm just going to sort of come back and sort of conclude what we've covered. So there are some common pitfalls I would see in cloud with threat modeling, and also when you're doing threat modeling in cloud. So one of them is thinking about cloud being the same as when you're thinking about a traditional data center. As you've probably seen so far, you've got all of these different types of something as a service, which are very different, and even within the application layers. All of those different layers that I had of an application were very different. Now that's not specifically cloud, but certainly the cloud resources are often very different. And the biggest issue to think about there is the second point, which is the shared responsibility model, and being very clear on that. And I think the debate we had earlier about, who's responsible for data in SaaS was really helpful, because that's an example of where you could fool yourself to be thinking, oh, I don't need to do anything about that. But actually, clearly you must do. And making sure you've got clear ownership, like a racing model for different aspects of the service. And another pitfall is if you've got pipelines that are doing things like automated builds, ML, machine learning pipelines is all the latest craze now. Okay? So anything where you've got some kind of automated pipeline and you don't think about things that could go wrong with that is another common pitfall. And the reason I'm putting this under cloud is automated deployment is very, very common in cloud, because you've got things like infrastructure as code techniques that get used, and you've even got GitOps techniques. People are familiar with that language, but the GitOps language is all about once you've published your updates to your thing to GitHub or whatever your configuration management tool is, the automation will automatically build and deploy that as soon as you've published it to the source code system. So if that's what you're doing, great. Now your source code system is your route to production. And that's the thing you need to defend against. So once you've actually committed something and put that into the main branch, it's going to go live. So if you allow that to be breached, you've now got code going into a live environment. So that's not specifically cloud, but it's used an awful lot in cloud. So threat modeling needs to consider all of the different layers, not just one of those, and it needs to be done differently in all of those different layers. And going back to my new buzz phrase, this sort of shift left thing, shifting the left, infrastructure's code adds another whole dimension. The landscapes that were mentioned earlier and policy as code and things like account vending are all things that only happen in cloud, and they have their own complications that perhaps the cloud team is going off and doing, maybe with or without input from security. My experience is the cloud teams are pretty damn good at doing, thinking about security. But it's nice to sort of get involved and help. So you need to think about SaaS. SaaS is an easy one to omit because you think it's all being done for you. We talked a bit about pipelines, and then ephemeral runtime. So things like function as a service or lambdas and things like that. They have a very different life cycle and different sort of threat modeling that needs to be considered for those. And doing this in a collaborative way, as I said at the very beginning, is really, really helpful because you want to get the inputs from lots of people, but you also want some outputs to be, you want to be sort of seeding some knowledge and some inspiration to the engineering team so that when they come to solve a similar problem come round, they're aware of some of the pitfalls and how they might deal with it. And just if you haven't done it, try doing threat modeling in some fashion or other and see how it goes, and come along and talk to us at a meeting like this if you want to sort of share your experiences. So I think that's pretty much it. So we've got the benefit, but I've talked about that more than enough. So that's all I'm going to cover tonight. So I know it's been a bit of a rapid fire, but I hope that's given you a bit of a summary of sort of some of the things that's gone on. Thank you. Let's give you guys on the call a quick look at on the check to see if so we've got some criticisms of what I've said, which is absolutely fine. I love the feedback. Okay, so what I'm going to say is anyone online, if you do want to speak or shout or specifically ask a question, I couldn't see any obvious questions that were in the chat previously. Apologies if I've missed them, but if you do want to call out or put another question in, they're very happy for you to do that. Okay, but while I'm waiting for them to type, so we'll take some questions in the room.
Early on, when you were talking about evaluating SaaS, you mentioned in passing SOC 2.
Yeah.
And it sounded like you were saying there's a good guideline that if you're having a conversation with a SaaS vendor and you're telling and you want to run down a checklist of, are they providing this? Are they checking that? Is SOC 2 that kind of list, or what were you referring to?
Yeah, but you don't really have the control as to what's in it.
No, sure you don't, but you could make sure that their SLA to you and the terms that you're signing up for their service include or validate against something like this, right?
Yes. Now, not every cloud service provider or SaaS service provider will want this.
No, but we can hold them to it. I'll try to.
I would always ask for it.
Yeah.
Personally, unless it was a trivial service that I didn't care about. And small organisations will struggle because there's a huge overhead in trying to make this happen. So if you are buying a service from a small organisation, you might want to bear that in mind, and depending on what it is, you might be happy to go ahead without it for a while they get themselves certified. But yes, I would suggest it's a good place to start, but you might not always get it.
And what is SOC 2? That's
so it's a set of controls around security. So it covers the whole. So it's a bit like.
I was just thinking there'd be a link to it somewhere.
Oh, I see. I haven't. Sorry, I haven't put a link.
That's fine. Thank you very much.
The American audit.
Yes.
So it's sort of like accounting audit.
It's much more stringent than ISO.
It is.
But it is also very costly.
Yeah.
So like when we do like vetting, we always look at like ISO, pen tests. Those two are like good enough. But if it's a big organization, they generally can afford a SOC 2.
Got it.
Okay, thank you.
Your types as
Sorry,
well.
can I jump in there? SOC
Type 1, Type 2.
SOC
Let the person online.
There's a SOC type 2 and a SOC type
Yeah.
1. So when a vendor goes through SOC compliance, it's SOC, not SOC as in SOX, which is a different thing to do with finances. SOC, SOC. Type 1 means they've been audited, gone through their controls, they've said what controls they're compliant to. The auditors come in, they've checked them and said, yes, we see you're doing those controls. They should then get audited again 6 months after that, and they should then be able to produce a SOC 2 Type 2 report, which then gives evidence of them actually actioning those controls and have evidence of them actioning those controls. So ideally, you want a SOC 2 Type 2 report, because it means that vendor has then been following up what they've been saying. If they're new to the market, they might only have a SOC 2 Type 1 report, but follow up with them afterwards to get a SOC 2 Type 2 report.
Yeah, thank you very much. That is a really good point. It's the Type 2 one that you want, because that's auditing evidence that they've actually been implementing and operating those controls for a period. Yeah, thank you. That's very helpful. Let me just check, see if there's anything else in here. So somebody, it's not a question, but a just useful tidbit here from somebody saying, I expand my threat modeling approach to a thing called Stride LM, where LM is looking at lateral movement. Okay. So there's another variation there. So anyone else wanted to raise anything now?
I think one of the things with threat modeling is making sure that you actually share the data. So obviously get everybody in the team, including operations, together and go through how you're expecting to operate it, what you're currently doing, looking at all the threats, but actually give that to the pen testers, because that's what you should have delivered against.
Yeah.
And that gives your pen testing team a real leap forward.
Yeah.
It can often be quite onerous trying to get pen testing out of people, because they go, what do you want us to test? And actually your threat model is what you want a pen tester to test.
That's a really good point, actually. I hadn't thought of that, because it's going even more than the typical white box. Yeah. Because white boxes sort of might be saying, okay, we can tell you about the design, but actually, saying go even further than that and tell them about the security controls that you're trying to protect against, and the threats that you consider.
It comes out of one of your slides, because you talked about what are we trying to do, how do we do it, but then how did we do? And how did we do are we as secure as we thought we should be?
And how did it work? What can we learn for next time? Check there's nothing else on here, but yes, thank you.
Sorry, it's me again.
Oh, no, that's great.
I also suggest that you revisit your threat models on a yearly basis as well. So there might be a lot of movement in that year and changes. So the threats you've identified when you first initially done your threat model might be totally different, and there might be a totally different landscape of that, and you might need to put additional controls around that in a year's time. So a threat model is not a one and done scenario. It is a incremental activity that should be done at least on a yearly basis and updated.
Yeah, that's really helpful input. Thank you for that. Yeah.
So I know you got the threat modeling as you're doing on the paper, while the diagram's still on a piece of paper, or while discussing a project is the best place to do it. But do you think that cloud is a great opportunity for more automated threat modeling, because it can read the
yes, you can do that,
and it can query the cloud. What got built?
Yeah, you absolutely can do a security assessment of the runtime system. Is that threat modeling? I don't know. You can split hairs as to whether it's threat modeling or security assessment, but yes, you can do that. You can reverse what's out there, and then if there are tools out there that then can take diagrams from that format and then assess those for potential threats in that design that's been implemented. It is a good point. You might actually want to say, well, we'll come and review. Let's just do an architectural review, of what's there.
Sorry, that's where sort of cloud security posture management comes into it, though, as well.
Yes.
So you do threat modeling, and you get your threats list lined up. You then put your controls in place. You then deploy your project. It then is running. You then use such cloud security posture management and your controls framework to ensure that there's no shift or movement in that. And if it is, that's flagged and alerted. This then sort of then goes into stuff sort of as supply chain elements to it as well, to ensure that you've got good supply chain coming up in and through. That there's no code changes, that developers aren't just changing stuff on the fly to make stuff work. So a good cloud security posture management tooling helps you with that, and it keeps you up to date and constant all the time.
No, thank you. That is really good, because one of the threats we were talking about, and one of the concerns, was misconfiguration. Misconfiguration could not just happen at the beginning, but it could happen at any point in the lifetime of the cloud asset. It could, by accident, as has been said here, something might have been fine at the beginning, but someone along has come along and tinkered with something, and then now it's not secure for whatever reason. Or maybe a new vulnerability has been discovered that just didn't exist previously.
When you're talking about pen testing, do you mean actual black box pen testing or just a code security tool like SonarQube?
When I was showing pen testing on the chart, I was talking about hands-on human beings doing it.
All right.
I sort of, you're saying, well, what about dynamic scanning?
Routine scanning, every time it is scanned.
So all of those activities require the asset to exist for you to scan it. Whereas what I'm trying to talk about here, or trying to get across here, is there are things you can do before you've even built it at various points in the life cycle of the thing. And the sooner that you think about the things that can go wrong and the design implications and the potential new controls, the better. Pen testing, you still absolutely will probably want to do that at the end. What you're trying to do is get to that point where you do the pen test and there's nothing interesting on the report. That's what we're aiming for. Yeah? Because nobody wants their project to be delayed at that point, because that's what's going to, and it won't happen, as I said. Yeah.
And the dynamic application security testing tools and fuzzing, I mean, you're getting a crossover between, things like Inspector, AWS Inspector, you get Code Insight, you've got SonarQube, you've got SNCC, you've got a whole set of tools that can work for you. So again, with the environments and the layers and the stages, you've done a really good job in breaking it down, but you can split hairs on each one of those phases.
So my view is they are not threat modeling, because they are after the event, they're after because you've actually now got an artifact that you've built. They are still really useful things to do, and absolutely you should be doing them. But by that time, it's sort of too late, because you've already written your code if you're going to do static analysis of your code.
Very little is greenfield these days.
That's true.
So the integration of what was and what is actually...
That's a good point as well, which is you might want to just go and assessment of what's out there if you're picking up a legacy application that you don't know.
And that also comes back to your point about little and often almost do little, because the team can say, we want to add feature X. Yeah. At that point, you can have a kind of a machine built threat model because they didn't do one originally, and now you can sort of say, well, we're going to add fancy colors. What does that mean to us? And then you're sort of threat modeling on top of a machine built threat model.
Yeah, that's great. So I'll take it back. I mean, absolutely, yeah. I think it's a really good idea, picking up on assessing what's there. If you've got an application that's been there for a long time, maybe the team aren't here anymore, or whatever. These things happen. And you want to know, what have you got? Is that threat modeling before you built it? No, but it's using some assessment techniques to help you understand the threats that are inherently in there, because you might have some hidden threats that the bad guys haven't found out about yet. So if you can get there before them, that is still worth doing. So
it's reverse engineering technique.
It's effectively it's part of vulnerability assessment, but it doesn't matter what you call it. It's a really useful technique. Yeah. Okay, let me see if there's anything else on. So we've got another point here from Ian saying a real challenge with threat models is the legacy systems. That's just what we were talking about there for operating organizations that the new cloud services connect to. Yeah, it's exactly what we're talking about. So thank you for that, Ian. Yes.
Question, in the spirit of shifting left. We do pen testing right at the end before we actually productionize it online. Is there any tools that can build into Python test mimic some of the pen testing aspects? Although, and few elements we can't, because you almost need to negative user persona based testing, but elements can still automate.
Yeah, so there are tools out there that will help you assess infrastructure as code before you deploy, if that's what you're referring to.
No, once it's deployed, to identify from almost at a runtime application, once the application is running.
You have something called IAST. You have dynamic testing. It is where you are like, as a user, you're testing that. Yes. You can automate that. Like OS, Zap is like free. You can script it, you can do that. And you have SAST, which is static code.
Yeah, which is static, yeah.
But you have another one, which is called interactive application security testing. That's what it is. It's an agent that sits next to the application and it can intercept. It works, and then think it's like, okay, how is the application responding? And then it's much more detailed and more reliable than DAST.
Exactly, because it's almost to a certain extent covering the areas of what an actual pen tester would do.
Replay and fuzz.
To make it even more interesting, you've got things like Zscaler that can start to do decoys for you. So you've got decoy infrastructure and decoy elements that then can pick up telemetry or negative use cases.
Yeah. So we had a talk a couple of months ago about observability. So that's all another part of it. I'm deliberately not focusing on all of those. Are really good techniques, and what we talked about with sort of different types of SAST and DAST scanning are really useful techniques. Cloud security posture management absolutely fits in as a, alongside the threat modeling. It helps you validate what you've done. I'm trying to focus on looking at things before you even create it, just for what we're looking at tonight. All of these other things, please do them as well. Okay, we've just gone 8 o'clock.